Hello, welcome back to Angular Orange, and today we're going to be talking about TypeScript. TypeScript is the foundation to Angular. It's a superset of JavaScript and ES5, and it is used for Angular primarily to provide strong typing for your development environment. Okay, so what is TypeScript? It's an open source framework supported by Microsoft that fully supports ES5 and most of ES6. It follows the ES6 and ES7 specs, but extends the language to support strong typing syntax. It's essentially a superset of JavaScript and uses the .ts extension. And then TypeScript gets transpiled into JavaScript. So in your project, you have these .ts files, and they eventually get compiled to .js files. Okay, so the Angular framework is written in TypeScript. It supports types. Developers can find and fix errors before running the app. It has great IDE support. You've got argument number types, context-sensitive help, code refactoring, etc. Type definition files are bundled. The IDEs provide type checking when calling Angular APIs. And it follows the EMCA script 6 and 7 specifications. It adds types, decorators, interfaces, generics, class member, variables, and keywords such as public and private. It provides interfaces. You can declare custom types and get help with compile time errors. And the generated code is easy to read. You have documented examples which are documented in TypeScript. So, like I said, TypeScript is transpiled into JavaScript. Typically, you could have TypeScript such as var title as a string or class book. And the transpiler converts that into ES5 language. So basically you'll have a JavaScript code which looks like var title and var book equals a function which is defined as a closure. And if you want to play around, I personally like just coding in TypeScript and making sure that the application works. I don't really delve too much into the JavaScript. If something doesn't work, I have to basically find a workaround. And so I do brute force production development, and you'll find that, if something doesn't work, you understanding why it doesn't work and waiting for a fix is probably not as reasonable as making sure that some other code implementation works. So that's my take on how you should work with TypeScript. And of course, you got your development environment. You've got Webpack, which does what it needs to do for the application. So it's hard to find out where the problem is when a problem does occur. You have to just get the most out of TypeScript and make sure that your application functions appropriately. And based on my experience, there's a lot there that works. And if something doesn't, it's easily to change the code and make it work. Now, I just want to point out there is a TypeScriptlang.org site, which is a playground for transpiling. You could actually cut and paste TypeScript code there, and it would show you how the code would get transpiled, and it's extremely useful. Okay, so installing TypeScript, there's one method that I recommend. I found that going from Angular 2 to Angular 4 was very problematic in getting your projects to compile properly and make sure you had everything in the packages. I found it to be a confusing mess. I couldn't tolerate it. Going from Angular 2 to Angular 4, I upgraded my WebStorm version to the latest version, and that installed Node and TypeScript 2 and Angular CLI capabilities, and I was off and running. And to me, it was probably one of the more better moves that I've made over the last couple of months, because you have to keep up with the IDEs, you have to keep up with Google, and the best thing to do is keep up with your versions of the software which you're using. And method 2 is run npm install -g TypeScript. Like I said with Angular 2, I tried this and I found myself npming and installing many things, and I just found it very frustrating. So the bottom line is, like I said, use method 1. Either use VS Code or WebStorm or some other development environment, and make sure that it supports Angular 4. But with the TSC, you could do a -version, you could transpile a main.ts file, you can determine how you want the code transpiled, etc. Okay, so transpiling TypeScript. It can be done locally. It could be done on the server during deployment, on the fly in the browser when the browser loads your application. And so I originally started doing Angular 2 with System.js. The loader was doing it on the fly, and I was perfectly fine with that. I mean, in the future, in a couple of months, I'm hoping I could point to a common directory network and not have to worry about a lot of things and make it all work. But going to Angular 4, basically, I installed WebStorm, and that used Angular CLI with Webpack, and so now Webpack Bundler uses a special TypeScript loader for compilation, and everything in development mode is pretty much handled. The packaging and bundler is done by Webpack, and then there's this server which uses WebSockets that connects with the browser, so when I change files, it would reload the browser with my new changes. And it is based on where Angular stands right now, it really is the recommendation to use something that's easier for you to learn TypeScript, rather than struggle with trying to determine whether your packages and your project is set up right. So use WebStorm, use the latest version, and move forward with your development. Now, you can compile code in memory, and it doesn't generate the .js files typically used in dev mode. So if you go into the TypeScript config file, you'll see a -no emit. I mean, I don't want to see the .js files. I don't really need to. My code's working. I've done many examples and several applications, and it's working. I'm kind of viewing the .javascript now as more of the assembly language of the TypeScript world. So, I mean, I know it's a harsh thing to say, but that's the way I see it. If you want to be an object-oriented programmer and make sure you use the objects and observables and everything in Angular, then you're going to try to get to that place. Okay, so and then also the TypeScript compiler has a /watch mode, and Webpack and Angular CLI are using this behind the scenes. When you do an npm run, the Angular CLI compiler does an ng space serve, and the Webpack server fires up and watches your code. Okay, so the pre-configured TypeScript transpiler process, you do have a tsconfig.json file, which is typically used in your development environment. If the file is in the project directory, it means you could run TSC on the command line, and TSC will read the options in the file. You know, if you're so basically, when you create a project with Angular CLI using WebStorm, all of these things are created by default with default values, and I personally have not touched them since Angular 2. With Angular 2, I was messing around with everything, but with Angular 4 and WebStorm, don't touch anything, just code and produce software that works. So most of these compiler options are set out of the box, and you can use them. And you could take a look at what some of these things look like. But like I said, if your application runs, just move forward. Okay, so let's get into TypeScript. There's things called optional types. You can optionally declare types for variables, functions, and parameters. For example, suppose you had a var title equals alien covenant. Okay, basically in TypeScript, you would basically say var title, declare it to be a string, and set it equal to alien covenant. Now, during development, the TypeScript transpiler can detect type mismatches. In addition, IDEs offer code completion and refactoring support. So if I declare a title as a string, okay, then I define, you know, I put a number in that particular variable, it'll be invalid. And even if I do a var title equal to a string, and then I try to define the title to be a numeric, it'll be TypeScript will say, well, we have an inferred type, which is string, so it's valid for you to now put a number in there. So TypeScript helps you develop code that would most likely work in a production environment and will catch problems when you're developing as opposed to at runtime. Okay, so there's basic keyword types like Boolean, string, number, and void. And these types are subtypes of the type any. Now, loosely speaking, any is a type where you could put any type of value in your variable. And you could use it for JSON objects, and even if you have an array with different types, etc. If you define an array of type any, then the elements can be numbers, strings, etc. So the any is used quite a bit when I get a compiler error and it says, oh, you can't really declare this as a numeric or a type based on the way you're trying to use it. I just turned it into an any because it probably makes sense. But anyway, you could declare certain variables as numbers, strings, booleans, and a string, and define it to be null, etc. A function declaration not returning a value uses the keyword void. Okay, so we do have a void keyword, and if type is not provided, TypeScript compiler will assume type is any. When you declare a variable or function argument with the type any, you are allowed to assign any value to it. Okay, so functions. You can explicitly declare parameter types and return values. So in a function, suppose I define a cost function, and I say the price is a string, the quantity is a number. And then I try to call that function with a quantity which is not a number. I would get a compile error. So the typing can really help you in developing your code appropriately so that there's no runtime errors. And default parameters are also supported. We have a function cost, and I say P is a string, Q is a number, and tax is a number, and it's equal to 0.06. This would mean that the default value for tax would be 0.06. And so I could call this function with two arguments. And so even though the definition includes a tax calculation, it would use the 0.06 for that value. So these two function calls yield the same result. One of them has 2 arguments and the other has 3 arguments. Typescript also supports optional parameters. Suppose you have a functional cost and you have 3 arguments, P, Q, and tax. The question mark after tax means it's optional. And so the function definition has to implement a 2-argument function call and a 3-argument function call. So if tax is one of the arguments, you could use it, and if it's not, then you don't tax the cost. Typescript supports arrow function expressions using anonymous functions and expressions. They can be simplified by using the arrow functions. So a variable getMovie, I could set it equal to left paren, right arrow, alien convenant. So notice I didn't use the left curly bracket, the right curly bracket, and I don't need an argument if it's not needed. So one-line arrow functions don't need the curly bracket. So I could do a console.log getMovie, and that would return the movie name. I could have a variable get uppercase movie, and I could define a movie and invoke the toUppercase function on it and return the movie. And of course, when I log getMovie, oh, that should have been get uppercase movie, it would return the movie. It simplifies the syntax. Okay, the other thing arrow functions do, which is extremely important, is it removes the confusion with the this pointer. Typescript passes the correct reference to the arrow function, so this points to the correct object. So if you have a function auction price, which takes a product string argument, you could say this product equals product, and if you set this is supposed to be interval, you could define the arrow function to say console.log the price for this dot product is, and since you're setting that off to the system to process that API call, and the event loop will eventually execute it, this will point to the appropriate product in the object, and so the this pointer would always work correctly. Okay, function overloading. TypeScript introduces function overloading, but the transpile code is a single JavaScript function. So if you have 2 functions, full name with 2 arguments and full name with map, you have to define the method so it supports both callable APIs. I have a function full name that takes a map name and a last variable. I have to actually interrogate whether map name is defined, is passed into the function call, or that map name is actually a string. So if it's a string, it's really the first call we're talking about, this one. If it's not, then it's this one. So you got to handle 2 different scenarios. Not too crazy about it, but it is what it is. Maybe it'll be stronger in the next 6 months or so, but since it's generating JavaScript, that's basically what we're left to deal with. Okay, classes. TypeScript introduces the class keyword. You could define an employee class with a name, title, and age. And when you instantiate employee, a new employee, you could then do a dot name, define the dot name, define the dot title, define the dot age. Now, notice these attributes are public by default, or else I wouldn't be able to do this. But it does get transpiled into a JavaScript closure, which I personally do not want to look at. Okay, there's constructors. So you can have an employee object and you could define a constructor. So you could do a new on employee and pass values to the constructor. Now notice the values, there's going to be type checking, so there could be an issue with this particular call. But constructors get called once in order to initialize object state. We have access modifiers. The default is public. Transcript supports access modifiers, public, protected, and private keywords. So you could have a public name, a private age. The constructor can construct the object with a name and an age, and the name is private, so basically you must use the constructor to define the name. The age is private, so you must use the constructor to define the age. But the name, you could pretty much define it explicitly with the dot notation. But on the bottom we show a compile error here where we're trying to log the age, and since age is private, you cannot do that. Private variable is only accessible from the functions of the class. You could put access modifiers in a constructor, and I love this about TypeScript. It's a simpler version of your class. If you put the access modifiers in the constructor argument list, TypeScript implicitly creates those variables for you, so you could pretty much use them. So the TypeScript compiler is instructed to create and retain the properties matching the constructor arguments. And this is very, very useful because other functions you define in the class would need access to those variables. So it's a simpler version of a class where you use these access modifiers in the constructor of the object, and then you have a method, let's say set name case, and that could also access the name using the this. So even though name does not appear declared, I could do this.name and put it and make it uppercase. So this variable employee, if this worked and I can instantiate the employee object, I could then set the name case, and it would turn my name into uppercase. Okay, there are static keywords that you could use in TypeScript. You define the class and you define a static variable and a static method which can operate on that variable. And then you don't need an instance of the object to invoke the method and have that method access the variable. So here my class name is employee.setCompany. I define the company name. employee.log company, the instance is not needed to log the company name. So here I did not instantiate the employee object or an instance of the employee class, yet I've invoked methods that access variables and log things to the console. You do have getters and setters in TypeScript. It's kind of interesting, and I want to say I have no problem with the syntax, but I do have a problem of when it works and when it doesn't work. Okay, so here's a class with a name, and you could set the name and use the to a value, and you can get the name with a value. And so what you could do is you could instantiate an employee, and you could use the dot notation to set the name. So this code will call the setName function and set the name of the variable to Steve. So it uses the setter method. So use it whenever you feel appropriate, and if you have problems using it, implement something else. Because there's different ways to implement all these classes. So it's if you find something that doesn't work in your development environment, I would not bother trying to figure out why, unless you did not have an alternative solution. Okay, so classes support inheritance. The JavaScript supports prototypical object-based inheritance. The object can use another object as a prototype. TypeScript uses keyword extends for inheritance, but transpose to the standard JavaScript inheritance, which at the moment I no longer want to look at. Okay, so I will be using classes if I define a class product with a title and a description, and I define a class book which extends product with another attribute. My book has an ISBN attribute as well as a title and a description attribute. So the book object contains the attributes of the product object. A book is a product. So here's what it would look like if I have a product with a title, description, and a constructor, and I have a class book which extends product. My constructor must invoke the constructor of the superclass in TypeScript. So I have a constructor which in the product object which takes a title and a description. My book has an additional parameter. My constructor must have an ISBN and also a title and a description, and I call the super method with title and description, and that calls the constructor of the superclass, which is product. So I could instantiate a new book using 3 strings this way. As you could tell, I like aliens. Oh, by the way, I'm using var a lot in this presentation. It really should be let. So you'll get a warning in your development environment. Let is a safer version of var, so use it. Okay, generics. TypeScript supports parameterized types which help define constructs of a particular type. Like, for example, an array of strings, an array of any. What I find is the array of any, I could put any object in an array. I could have a numeric, a string, an object. You can construct an array of anything, as long as you declare it any, and as long as you retrieve the array elements as any. So, for example, suppose we had a car with a constructor, and that constructor set the state of the car object. Then I could define items as an array of products. And what that means, it's any object that inherits from product. So I can instantiate a new product and define an array element. I could instantiate a new book. Book inherits from product. So I could define a new book and put it in item 1. I could define a new car and try to set it item 2 to the new car. But I would get an error. A car is not a product. So I cannot put a car in the array of products. So this is the strong typing that we're talking about that TypeScript supports that would help you compile time as opposed to runtime to help you develop your applications. And notice if I do array of any and I declare this all items as an array of any, it's okay for me to put a car into the array. As a matter of fact, I could put anything into the array as long as it's a valid type in TypeScript. So generics you use quite a bit because you're constantly working with JSON objects, and I usually define JSON arrays of JSON with generics, and I use the any type typically. Okay, interfaces. TypeScript provides the keywords interface and implements. If class X implements interface Y, then a class X must implement the APIs in interface Y. So here's an interface called the car interface. I got a model, type, and a year. A year is optional. I declared the iCar interface was an optional parameter year. So now class auto, which is a constructor, uses the constructor and defines a public configuration inside the auto class, which is of type iCar. So this is one way to use an interface in a constructor, and the iCar, you don't have to implement the iCar interface. You could pretty much define a car of the type iCar and that object, and define that object with a model, a type, and you could leave out the year because it's optional. You could define a new auto with a car because a car is type iCar. And then you could log that mycar.config.model, and it would show you that it's a Toyota. It's an interesting perspective. Do I like it? I'm so used to implementing. It's hard, but it's hard to grasp and use. But the bottom line is you don't have to implement with this particular implementation. You do have to do a dot on the config, which has the implementation. So it's a way to declare variables with an interface, and then reference use those in a constructor and reference those with a dot notation. So determine whether you're into using something like this and whether it would be useful. The readability of code is extremely important, and I find this a little bit different to read from what I'm used to. I spent 30 years looking at implementing interfaces, so it's a little bit different. Okay, and you could also use the implements keyword, right? You got an interface iBenefits, add benefits, which returns Boolean. So that interface I could implement. So an employee can implement iBenefits, and a temporary employee could implement iBenefits. And so when you go to add benefits to these two different types of objects, that being one being employee, one being temporary employee, you could have different implementations. one, you could add different types of benefits than the other. Temporary employees typically only get benefits if they work. Well, they typically don't get benefits, but my implementation says if the days worked is more than 365, add the benefits. So I'm trying to implement a situation here where a temporary employee could possibly add benefits and pay for them, of course, in the event that they have over a year of time put in. Whereas an employee add benefits, you always return true because you're always going to be able to get benefits. So here's an example. Employees is an array of I benefits. Here's one employee in employees sub 0. Here's another employee in employees sub 1. And then you use the array dot for each to add benefits using the notation. Well, I'm going to say the arrow function to say that add benefits for each employee in the employees array. So this is really sweet syntax, and the code is really simple. So I mean, it's simple enough. So we like TypeScript. It is very strong with interfaces, and you could do really nice things with it. Okay, now there's also the concept of callable interfaces. We're all still trying to I mean, this is extremely powerful stuff, and it's very, very good. But we're also trying to swallow this and try to say, well, you know, is this going to work? Is this not going to work? Should I use it? I'll be very honest with you. It's not working in my WebStorm version, and I've coded up several different examples, and at the moment it's not working. I've decided to move forward and not use it until it does work. And I'm anticipating a new version of WebStorm and Angular 5 to come out in a month or two, and I'll try it then. But it's pretty nice. You declare a bare function signature with no function name. So this is your interface. Then you implement the interface, and you have the constructor invoke a function that uses the interface. And that allows you to define rules for different types of objects. So even though you have the interface and you're adding benefits with different types of objects, they have different implementations, and the rules inside the implementations can change. And I'm thinking about this now. As I think about this, it's sort of like the operator overloading. The only thing is that it's different in the sense that you don't have to define the different declarations of how you're going to call it. You could change the implementation and the rules without changing code. So it's much more flexible and extensible and scalable, but it's still it's still a little different. And then also, the more I think about it, is you got visualization rules, you got certain rules in the presentation tier, but the question is, where are some of these rules supposed to reside? Rules engine, middle tier, Node.js. Is it supposed to be in a Java application server? Is it supposed to be in a web service? You know, so you have to don't abuse this, but definitely visibility rules and internationalization and other things you could probably use this for. So here's the other rule for temporary employees, you just return false. So here's our example. You instantiate two employee objects passing different rules for adding benefits. So here, and notice the interface is different. Here you have an employee, and the rule for employees gets passed, and here you have an employee, and the rule for temporary employees gets passed. So, and then when you go and use the for each function against the array, for each employee in the array, you add a benefit. So the first method call on the first object in the array uses one rule, and then the second employee in the employees array uses a different rule. And like I said, it's implicitly a little bit more complex than operator overloading, but it's still extremely powerful. Okay, classes as interfaces. This is another TypeScript feature which I am personally still having trouble with, but you could use classes as interfaces. With TypeScript, you could think of a class as an interface. If you have a class A and you have a class B, you can say class A implements class B. It's legal. I've been avoiding it. Okay, class annotations. This is the beauty of TypeScript. You basically can you have TypeScript decorators, and you can provide a way to add metadata to your code to turn the TypeScript class into a component. You annotate it with the at component. Okay, so if I import a component from Angular core package, I could use that annotation at component. That component probably should be in uppercase. And I could have a selector user and a template user view, and I could attach that to my class user component, which has an attribute username, and the annotation processor, which is really the Angular compiler, parses the annotation content and turns it into code that the JS runtime engine understands. So we use annotations for everything in Angular. We use it for declaring modules. We use it for the component tag, directives, pipes, etc. A TypeScript class with an annotation turns into a component, or turns into a directive, or turns into a pipe. Okay, so just a quick word about type definition files. There's a repository for type definition files. They are files suffixed with the d.ts. They're bundled with Angular NPM packages. Their presence in your project will allow the TypeScript compiler to ensure your code uses correct types. You can do an np install the types jQuery, and you'll get all the types you might need. Like I said, the best thing to do is install WebStorm's latest version, and you'll get everything you need. When you create a project with Angular CLI, everything is there for you. You don't have to struggle. If you do an npm install, do a .save-dev so it updates your package.json file. So the TypeScript, the type definitions are installed in the node modules directory, and you can go there and take a look at the different types you have. If you get a type error, do a little research, and maybe you might need to install something. But I personally have not had to struggle with this. First of all, I use Angular 4. I don't use jQuery. So right now I'm using Material Design. I know if I was using Bootstrap, I would definitely need jQuery. But I'm not using Bootstrap now either because the Shadow DOM and Material Design appears to be a good fit. Okay, so in our next tutorial, we'll go through a TypeScript example. It contains examples that demonstrate using several components, different TypeScript features, and you would find an extensive lecture in our course, and you'll find some tutorials floating around as soon as we find time to publish them. Thank you very much for your time.